going you to present the story of AMFI, not everything. We are with the two of us. I'm Roger Gerards, I'm head of fashion and design, and Sandra Kuijpers, who will do the rest of the presentation, will tell you something about the research she is doing. AMFI is part of the Amsterdam University of Applied Science, and we have also a lecturer, a research group of fashion research and technology. The bachelor course is offering study in design, branding, and business development. And in that we have the whole supply chain in the study. And I'm going to tell you a story about hybrid learning, digital physical learning, a minor we have called Hypercraft, and a little bit about product, and then Sandra will do her presentation about the research field, stand and drape, about qualities of textiles. So, well, most important is the change in the industry. This is a research which has taken place by Fashion Tech Alliance some 2 years ago, and these are all new job descriptions related to digital developments. So as a study, we are looking at that and aiming at that. And some remarks we find with having discussions with the industry is that a lot of knowledge is needed on physical aspects as textiles, pattern making, construction, more even than in the past because of the switch to digital. And that's a spontaneous response we get back from all the businesses we are working with. And of course, no standardization, the workflow has to be changed. We need to make new education, sustainable objectives is always on the table. And collaboration is also something everybody is saying because of the change in the supply chain. We have a lack of a lot of trained people, even in our team. I have a team in total of 106 teachers and lecturers, and still we need to find people who can train on digital skills. We need to find new workflows, we need to interconnect between software, we'll come back on that, and a lot of investment is needed. Time and people is also money, so it's a lot of money is needed. We have graduation projects since 2006 on digital. There are students who graduate totally digitally, sometimes also more and more now for the gaming industry. And also students start making avatars for their own and clothing for their own. And the connection with other industries is becoming big. We work digitally already since 2006. We had the first student who had graduated in 2006 with a digital collection, hybrid. What we are doing, and Miriam Ingram is a teacher who is defining that course, is we have the vision that we have to train students always phygital and digital together at the same time. So when we start in the first lesson with learning them to learn the machine, the industry machine, they immediately learn in a digital environment the connection between 2D and 3D, and that goes on. And at the meantime, we also do draping and pattern cutting and making it. So they have all the relationships all the time via the digital and physical way. That means in week 8, they already make this dress and they drape skirts like this. It goes very quick because of that, because the insights via the digital environment help students to understand the physical immediately. Much quicker, much closer, because they work with bodies more than in the past. Because you work with bodies all the time. So we do draping. We have a lot of lessons per week, and per week they learn a western skirt to make, even on a strange avatar, jacket, designer skirts. And in that time that they do everything together, they also have their own project, which is also physical, digital. So this is the first experimental design they are making. And in that process, they also keep on training in pattern making, construction making, and also executing their own design, which they has to transform from physical to digital to physical too. This is done in 20 weeks, and this is their first experience with making fashion. Because of the digital tools, they learn twice or 3 times quicker than in the past. Their insights grow immediately. So we go on that. Then they also make very complicated tops, and they have to make it by hand with couture techniques. So we combine couture hand techniques with a digital development process. In their own collection, this is the first time they make a collection, they also have to combine printing, knitting and craft techniques also within physical digital. So we expand from pattern making and making of garments also the combination to other craft techniques. I'll just show you quick what it does. So we have a lot of training in it, but they experiment in what they design themselves, how they are developing it. It's also fashion drawing or sketching, but also sketching in a digital environment. What we see is that the detailing and implementing craft to the design works very quick, and that the focus on detailing becomes much more during the process, because you don't need to have fitting sessions to do that. You do it all the time because you can go to detail immediately. And that results in a physical product. This is this learning path that we are doing as a start and now implementing to the whole course. Then we have a minor hypercraft, and the focus is on workflow. Students work for 18 years on a digital product. It can be branding students, business students, design students. They make their own project, and what I want to explain is that they define everything with the software we give them, and we see that they use the software in a way it's not meant to do. This is a project in which the student Jules started sketching, and then in another program he starts making it in 3D. Then he is applying details to the design. He's texturing with another program and really now developing his own textiles, but also his own hardware. So the hardware is printed with another software. Then he starts going back to posing and what he wants to do for a presentation. He's attaching the closures to the garments, and then he is going via laser cutting, making the garment himself. Everything is done via software, via digital ways, and he makes one physical garment from the collection he has designed. Also, and this is what students want, this is a design student, but they also want to do the presentation. So in a way, they do the whole supply chain because of the possibilities of the software. This is a student who developed print by coding in software. So she uses the software totally different to get an own print design. And this is her collection, but our objective is especially to find this. What is the workflow of this project? And here we also study the combinations between the software and how you can work with it. These are students who do this after 1 year or 1.5 years already experience with software. This is the last projects in which you again see that we're studying the workflows. And then they all film their workflow, so they also can explain to others what they did and what follow up, and how they attach it between the different software. So even the software itself helps us to register the process. We discovered that designing the process is more important than designing the product. Quickly, just to mention, attention to avatars is becoming more and more. It has to do with inclusivity, but also movement can be designed, and movement can also have a direct relationship to the product. And students love it, and they even get money for selling the avatars to whoever wants to buy it. So this is already happening during the study. Just to mention, I'm not giving attention to this. This is a product department within the business in which we also work with suppliers and tech pack and all the ching-chabang on that level. I don't want to explain that much on this because this is what we have to do and a lot of studies are doing. And that also has to do with body scanning, fitting, and all this knowledge which is required from the industry. Then we have the Fashion Research and Technology Department. Just 2 projects to mention. We have a collaboration with a lot of schools and industry about developing modules for industry and education. That means that on the topic of digitalization, sustainability, business and finance and engagements, we make modules you can get free for schools and for industry on 4 hotspots or spots in Europe. And this is a European collaboration also to work on that level in the current developments. This is another collaboration with 3 partners in the Dutch educational environment. We are on data development and data engineering and design. There's a project on new aesthetics in the school in Arnhem, the Artes, and there's biodevelopment project. We do this very intensively with business together in the schools. We have more projects on this level. So now we come to one project also in that the field of the organization done by Sandra. And this is Sandra.
Hello. My research, what I just presented at the TAI conference 2 weeks ago in Cork, is about unweaving the physical versus digital design considerations. And you can read it. There was a QR code, but I can send you the link. You can find it easily online. Through the physical engagement with materials, designers, product developers, people in our industry, they understand a lot about fabrics. I was even surprised when I did the research with students how much they knew already. Today, we are in a digital environment and designers need to consider a material on a computer screen. And we heard already a lot about the talk this morning about the limitations. Safia addressed that really very nice, the tangible missing. What we often see, and this is a sort of extreme example, but I thought, okay, we see those things, the difference between the design, digital, and the physical. This is also using puffer to get this. But then we often see that the real product has a gap. And often it is due that students use the sliders in the program and they start with the basic fabric which is in the program. We put a lot of our basic fabrics in it, but still they always have a different fabric. And that's a lack of knowledge, lack of time that they use this process. Because we also have all the facilities in our lab to test the fabrics on the claw kit, on the fabric analyzer, and also with a more sophisticated instrument, tensile tester. In textile science, they use objective measurements to measure fabric properties. We use that in 3D now. And they have a heritage in textile science, started almost 100 years ago, and still we use those technologies. And there really some things are good, we don't need to change it, and some things we might be able to improve. What you see is drape, and we need a new understanding. And I see a lot of examples, people using drape to compare between physical and digital. And I set up a workshop with 20 digital fashion designers and 10 really different fabrics. And they had to go first through a tangible phase, touching the fabric, and giving their design considerations for the textile. Then they had to observe the drape without touching, and then they had a reflection phase. And during the tangible phase, they were not aware about what was the next phase. They knew only that there were 3 phases. We also had, I also had each phase a presentation and guiding questions. And they stressed, after they went through the whole process, they stressed the importance of the tangible interaction, and that they could say more when they felt the fabric. And that it was challenging only to look at the properties. It looks more stiff, but it isn't. It's actually quite soft. They felt that. And perhaps it's familiar to you. You recognize that yourself. But also, by observing the drape, which is quite interesting, their understanding increased of the textile materials. And that is also very interesting to become more aware of it. Perhaps I knew that in my heart. But if you can decide that it would create a different type of drape than you intentionally think or thought, then that is helpful to design more purposeful. And also some really changed their design considerations for the textile. So that was also valuable insight. And we think that it goes beyond adjusting sliders, and that designers also need to understand a little bit better about these textile properties, what the effect is. But sometimes we adjust the sliders because of limitations we are in. Perhaps can also be limitations in the software. What we found also is that designers use phenomenological and post-phenomenological experiences to build their design considerations on. And I think it is really important to be aware of that, and also that the potential of the combined tools will be super helpful, I think, even in physical environments, but also in digital environments. And we see already a lot of drape happening. Visu has some draped shapes on their stand, and future research I'm busy with is increasing the design considerations between those processes, but also more understanding of the physical and the digital drape, using simulated properties, and standardization of those measurements, textile measurements, the measurement system, and because they create a lot of hurdles. And I'm talking since 2016 at PI about that. Sometimes people ask, in 2022, someone asked me, why are you doing this? And I think today's the last time I do it. But it is cross-disciplinary what we need to do. And I think we have already we are analyzing it, some super cool drape tools that everybody can use in digital space, but we are now analyzing the data, and we have to make the tools. But that's, I hope I can publish that really soon. You're always welcome to visit us. Please visit us. Like Roger already said, that we would like to collaborate, and we would like to show what we have. We have also a lot of other things. I would like to look back to 2019. A lot of wins, what we did from that same location, and we really have a lot of wins. The 3DRC Education Committee, we had this panel, and perhaps you know some of the persons. With Christiane Louible, I did a publication on the measurement of properties that was by that time already almost ready. And so we published that, and that gave a lot of insight to build further on. And then the 3DRC, they took it further. They have really very good documents with the SOP, standard operating procedures, and the digital physical interoperability. I think in that document there's a valuable curve, and I will come back to that curve a little bit later on. And then afterwards we published with Modint and EAF a paper. It was addressing the mills, because we wanted to have the mills on board to measure it. But there still is a hurdle to get the mills on board. We are now cutting really a lot of different swatch sizes. This is just an example from when we are testing, because we test also with the different systems to learn from that. What are the differences between what we measure, and what are the properties, because we measure only how it bends, how it stretches in all directions. So we would like to try to correlate between them. And Visu made already a nice tool to exchange those properties. But still, it is a little bit gray area today. And it came also clear on the talks I had this PI that some people, they have solved it for themselves and they are a step ahead. Some companies, they really work in a way that I think, okay, yeah, this is the way, what we also figured out. But it took us really a lot of trouble and effort. And also people who are saying, we are not there yet. We only use it now in this area. So I think that's also important. Perhaps it's important for the 3D RC or for us as AMFI or another podia to exchange this knowledge, because we don't want to waste time, I think, and we also don't want to waste material. If perhaps, from sustainable perspective, it's not allowed anymore. But it's also for my research a threshold, because I had a super cool invention with AI, but because of lack of data, because it holds me back that I have to test it with so many devices, I couldn't run the AI, which would also help us a lot. And the findings from this AI are really very positive. But lack of data. So for me, it's time for change. The change, what we did from PI 2019 to Praxis. Peter Goodwin, he's from James Hill, developed the Titan, and they developed the Titan, and he made with another large company in Europe. He made a software for this Titan. So we can measure, instead of the claw kit, what you see on the left side, manual measuring with a lot of mistakes we have when we do that, because we have to turn it manually, we have to write it down manually, and the force couch is running down. So when do you need to capture it? And if you look at the Titan, it's just computer controlled, so that's really big help. We use the ISO standards, and I heard yesterday a lot of people who are using the German standards. I believe there's a little bit difference. I also found out last Friday by research a student did that for knits there's also quite a difference, and that was regarding fully fashion knit, what we did on the Shimashaki. And I found out yesterday evening how to measure knits. That's also new avenues for that, so that's really nice. This, we can get everything out, and if we ask the developers of this thing, they can tweak that, what we want to get out. So we have now a translation for claw. We get out the data for claw, and we tested that when we compare it with the claw test kit. It looks really good, but we have a long ferry row with a lot of numbers. And basically every software could pick on every force their data, their extension, because every software uses a different combination of extension in millimeters and the force. It is all in a low forces, like how we move, how we bend. So that's, I think, nice to have. I'm happy with it. And we also then discussed the shear measurement on this bias extension. Now, that works also. We are testing, exploring new avenues with friction, because I think in a simulation it is also important. When we wear garments, the friction with your body, the friction with the material on the material, that's really key thing in our simulations. But I think years ago it was more important than it is today. But we are going to test with it, because I think it can improve our simulations. I'm doubting about stretch recovery. We do also yarn testing for our knitting. But the quality testing, this is the same standard, only a different load cell we put in. And then we have quality tests. And they are usually done in a mill. And so they are already familiar with these tests. So our stretch test, yeah, can easily be pushed. I spoke with mills and they are convinced about it, that they can do it in that way. Now, this is at night, sometimes when the computers work at the AMFI, rendering, and that is, yeah, all the hard work, all the fabric calculations, and their crazy designs.
Thank you.